Today we are going to be looking at determining the midpoint of a line segment as well as the distance of a line segment. So first we're just going to start with the formulas. They are pretty easy to just fill the coordinates into and solve. So the formula for midpoint is given by a capital M, not to be confused with the lowercase m that we use for slope. And the formula is given by the following. It's written as a coordinate because it is a point, so we're showing it as a point or a coordinate, and it is x1 plus x2 divided by 2, and y1 plus y2 divided by 2. Okay, so you're finding the average of the x coordinates and the y coordinates for your 2 points. Okay, so this is given 2 endpoints of a line segment, and those endpoints would be x1, y1, and x2, y2. Okay, so if you are given the 2 endpoints of a line segment, you are just substituting in those values for your x coordinates and your y coordinates and calculating. So we will look at an example for that in a moment. The distance similarly uses 2 endpoints, x1, y1, and x2, y2. And the formula for finding the distance between the 2 points, or in other words, the length of the line that connects those 2 points is a lowercase d for distance is equal to, the whole thing is under a square root, and we do x2 subtract x1 squared plus y2 subtract y1 squared, and that whole thing is square rooted. It's a bit of a not confusing formula, but there's just a lot going on, and it is derived from the Pythagorean theorem. There is a video on Brightspace kind of explaining that if you are interested in where the formula comes from. But again, this is given 2 endpoints, and those endpoints are represented as x1, y1, and x2, y2. Okay, and the important thing to remember here is that in the midpoint formula, we are adding between our coordinates. In the distance formula, you are subtracting between the coordinates. Okay, so subtraction here as well, but then the numbers that you get after squaring, you're going to add. Okay, so we'll take a look at an example of that, but just be careful that when you are doing questions with midpoint and distance, that you are calculating everything correctly. Okay, it's pretty easy to substitute values in, but there can be some times where it's tricky with the signs if you have negatives and you're subtracting negatives or whatever it might be. So we are going to look at an example of how to use both of these formulas. So if we are given the endpoints -4, 2, and 8, 7, we want to find the midpoint between those 2 points as well as the distance. So first I'm just going to label my points so that we know which numbers we are putting in where. So I'm going to call this coordinate x1, y1, and this one x2, y2. Okay, and then first I am going to do the midpoint. So we said that my midpoint formula is set up like a coordinate. We do x1 plus x2 divided by 2. Okay, so I'm not going to write the blank formula again, but I'm going to just fill in my numbers here. So I'll have -4 plus 8 divided by 2. Okay, that will give me the x coordinate of the midpoint. And then for my y coordinate, I'm going to do the same thing. I'm adding the 2 y coordinates, so 2 plus 7 and dividing that by 2. Okay, so now I'm just going to simplify a bit. You could just go to the final answer if you wanted to, but I'm just going to show the in-between step, and you just need to make sure that you are confident with adding and dividing in your head, or if you're using a calculator, so that you can get the correct answer. Okay, I often see students set this up correctly and then try to skip the middle step, and their answer ends up being wrong because they're trying to do math too quickly in their head without showing enough work. So -4 plus 8 gives us +4, and then we will divide by 2. And then for our y coordinate, we have 2 plus 7, which is 9, and that's going to be divided by 2 as well. So then the last step here is just to evaluate both of those. Okay, so 4 divided by 2 is 2. 9 divided by 2 is 4.5. It's pretty common that you will have a 0.5 coordinate, but because we're always dividing by 2, it will be a nice decimal like that, so it's fine to write it as 4.5. Typically, I say keep things a fraction, don't leave it as a decimal, but in this case, it's easier to have a point, the coordinates of a point, as a decimal number, because when you are plotting them, you should know where 4.5 is on the Cartesian plane, whereas when you look at 9/2, that's not as clear as to where it is located. Okay, so that is the midpoint of that line segment, and if I were to graph those points and then graph the midpoint, I would see that the distance between one endpoint and the midpoint is the same as the other endpoint and the midpoint if I were to measure the distance there. Okay, so speaking of distance, we're going to find the distance between the two endpoints. Okay, so again, I'm using that formula that I wrote before. I'm not going to write the blank formula, but I'm just going to go ahead and fill it in here. So I'm doing x2 minus x1. So we have 8 subtract -4. Okay, so this is where it could get a little bit tricky because we are subtracting a negative. So I'm going to show that here. If you understand what is happening there, you can write it as a plus. But I just like to write it like this to show. And then that whole thing is going to be squared. Then we are adding y2 minus y1. So 7 minus 2, and that is squared as well. And then the whole thing is going to be square rooted. Okay, so I'm going to go step by step following BEDMAS. So first I'm doing the brackets of each. Okay, so here I've got 8 subtract -4. And again, we talked about this with cosine law, but when you're subtracting a negative, it becomes a positive. Okay, so this is 8 plus 4, so it's going to be 12 squared. Then we are adding. 7 subtract 2 is 5, so this is going to be 5 squared, and then square rooting the whole thing. I'm going to show every single step here, but as you get comfortable with doing this, it's okay if you skip a few in between steps. Like, I would show this step at least, but if you don't want to show this next one that I'm writing, that's fine. So now I'm going to evaluate both. So 12 squared, 12 times 12 is 144. And then we are adding 5 squared, which is 25. Okay, so then I'm going to add those two numbers together, and I have the square root of 169. Okay, so then the last thing that I need to do is just evaluate that square root, and this is a rare case where your distance is actually a nice number. So if you take the square root of 169, you get 13. It is not uncommon for the answer to be a decimal number. In fact, it is pretty much all the time. It's always going to be a decimal answer, so don't panic if you calculate the distance and you get something with a messy decimal number. That is fine. I typically round to one decimal place. You can keep two if you'd like to, but don't round to a whole number unless it actually evaluates out to be a whole number, like if it's a perfect square. And then we're not given the units, okay, so unless the question states that each square on the Cartesian plane is 1 centimeter or 1 inch or whatever it might be. We don't know the actual units, so it's fine if you just write d equals 13. I usually will write 13 units just because it is a measurement and it is in some unit. We just don't know what that unit is. Okay, so that is the distance between the two endpoints there. Something I do want to point out before moving on. In this example, both of these values here ended up being positive when I evaluated, but sometimes they end up being negative. Okay, so what I mean by that is maybe you would have like -12 squared plus negative 5 squared, just depending on what your coordinates are. Or even like if I had of changed which points were x1, y1, and x2, y2, like if I swapped them, then you would have got this, right? If we did -4 subtract 8, you would have had -12. It's important to remember that whenever you are squaring a number, you will always get a positive answer, okay? If you do this on your calculator, you will not always get a positive answer because your calculator does not know how to do BEDMAS correctly. So if you type in -12 squared, you likely will get -144. However, that is not correct. You need to either type it in with brackets on your calculator, or you can just think, okay, so something, when we're squaring a number, it means we are multiplying it by itself. So this means we are doing -12 times -12. And we know that a negative multiplied by a negative will make a positive. So this is still just positive 144. Okay, so although your calculator might tell you it's -144, it is not. And similarly, if we had -5 squared, that would be the same as 5 squared, so it's just positive 25. Okay, so it's important to note that whenever you are, like when you get to this part here and you are ready to square these values, you will never get a negative answer. Okay, if you do, just get rid of the negative and write it as a positive, because one, it's just mathematically not correct, and two, if you end up with a negative under your square root, then you cannot actually evaluate that root because it's impossible to square root a negative number when we are working with real numbers. Okay, so just keep that in mind, either that you're going to type it in with brackets here, or you're just recognizing that negative, like the square of a negative number, is the exact same as the square of that same number that's positive. Okay, so the last example with midpoint that we are going to look at is how we can find the coordinates of an endpoint if we are given the other endpoint and the midpoint. Okay, so in this case, it says the line segment has an endpoint with coordinates -5, 7, and we know that the midpoint is -2, 2. We want to find the coordinates of the other endpoint. Okay, so we know that the endpoints, the first one is -5, 7, and we don't know the coordinates of the second endpoint, so I'm just going to call it x, y, so that I have some variables that I can solve for. Okay, and my midpoint, I know that the value, once it's evaluated with that formula that I gave you, is equal to -2, 2. Okay, so what I'm going to do is I'm going to set up my midpoint formula as usual. The only thing that's different here is that my x2, y2 point, I don't know actual numbers for it, so I'm going to just put in x and y. Okay, so I'll show here, this will be my x1, y1, x2, y2. Okay, just so that you can see for where I'm getting my numbers from my formula. So the midpoint formula, I'm going to do x1 plus x2 divided by 2. So I'll have -5 plus x divided by 2. That will give me the x coordinate. And for my y coordinate, same thing, I'm doing y1 plus y2. So 7 plus y divided by 2. And that gives me the y coordinate. Okay, so although I do not know x and y, I do know what the solution is for both parts of the coordinate. Okay, so I know that whatever I'm subbing in for x here, if I add it to -5, then divide that by 2, I will get -2 as my answer. Okay, so how I typically show this is I just kind of put an arrow over here and I say that I know -5 plus x divided by 2 must be equal to -2. Okay, and I know that because I'm given the midpoint. So whatever I put in for x here, I can set up this equation and I can calculate. So because we are dividing by 2 on the left side, the first step is always going to be multiply the whole side by 2, okay, because that will cancel out the denominator. And then we need to multiply the other side by 2 as well to keep it balanced. So we will have -5 plus x is equal to -4. Okay, and then I just need to isolate for x by bringing the number to the other side, right? I'm doing the opposite operation, so it's -5, so I'm going to add 5 to cancel it out on the right side. I'm going to add 5 on the, sorry, I think I said right side. I'm adding it on the left side and the right side. And then I have just x left on this side is equal to, and negative 4 plus 5 is positive 1. Okay, so that's my value of x. Then I'm going to do the same thing with my y coordinate. Okay, so I know that whatever whatever y is, 7 plus y divided by 2 must be equal to positive 2. Okay, and again, I know that because I'm given my midpoint, and so I know that this has to work out to give me positive 2. So same thing, the first step for when you're doing a question like this is always going to be multiply both sides by 2 because your midpoint formula is always being divided by 2. So then you will have 7 plus y is equal to 2 times 2, which is 4. We want to isolate for y, so we're doing the opposite of 7. Even though there's nothing written in front of the 7, it's a positive, so to get rid of it, we're going to subtract. Subtract on this side as well. And we end up with y is equal to negative 3. Okay, so we know both the x coordinate and the y coordinate. So the last thing to do is just to state our final answer. So the question is asking to determine the coordinates of the other endpoint. So we can just write a therefore statement or sentence answer. We'll say therefore the other endpoint is, and we'll write it as an actual coordinate. So that point is going to be 1, negative 3. Okay, so that's just the proper way to write it for best communicating your answer for full communication marks. Okay, don't just leave x equals y equals, write it as an actual coordinate, and that is the other endpoint. And the nice thing about this is that you can always check your work by graphing if you would like to. It is more effort and more tedious. It's not necessary to check your answer, but that option is there if you are not feeling confident, especially when you're starting out. Otherwise, the two formulas are pretty simple. Once you've practiced a few times, it's the same thing over and over. You're just plugging in your numbers and calculating.